Hello everyone, welcome to Fahad's tutorial. Today I shall be explaining about dimension, a little bit about dimension. In physics there are two types of quantities, fundamental quantities and derived quantities. So in these physical quantities we know that the physical quantities are combination of some fundamental quantities. Like if we just say about area. So we know this area is actually the multiplication of length and breadth. So we know in case of volume also, we can see that this is actually the multiplication of 3 length. So in this case, we know this is the fundamental quantities, actually the length, and this fundamental quantities creates the physical quantities. So if you want to define the dimension, we can say that the power, this is very important to know, that power of a fundamental quantities in physical quantities is called about dimension. So to know about dimension, we need to think what is the power inside of the fundamental quantities. Like if we say about velocity, we need to think the definition. The definition is velocity is displacement over time. So we can see this displacement is actually a length, and this time is all about time, and this is a fundamental quantities. So these fundamental quantities actually creates this physical quantities, which is velocity. So if you need to know the power, we need to think this displacement is actually a length. So in case of expressing the dimension, we need to use the capital letter. So it would be L over time, because this is displacement is all about length. If you want to say that this is speed, then this would be the distance, and again distance itself a distance and length. So here L over T is the dimension of velocity. So it would be, if we know that, it would go over and it would be like LT inverse 1. In case of understanding the acceleration, what is the dimension of acceleration? So acceleration is actually the change of velocity. So we can write this is velocity over time. So if we just want to find out the dimension of acceleration, it would be the dimension of velocity over time. Here we just find it out, this is LT inverse 1, so L over T over T. This would be the dimension of acceleration, and hence it would be L T inverse 2. So if we need to think that how we can find this dimension, like if we just say about a derived quantity like force. What about force? We know that force is equal to the mass into acceleration. You know it already. So this mass and this acceleration is the multiplication of force. So the force is the result of multiplication of these two quantities. So this is physical quantities. We know this mass is a fundamental quantities and acceleration definitely derived quantities, because it will be coming from the velocity over time. So if we need to know the dimension of force, then we need to think mass itself a fundamental quantities. So the power is M, this is capital M, times acceleration, that we just find it out, L T inverse 2. So if we just multiply, we will find the dimension of force. So it will be M L T inverse 2. So in case of defining the dimension, we will say the power of fundamental quantities in physical quantities are called dimension. And we must know these three fundamental things is mass, In case of mass, it would be capital M. In case of length, it would be capital L. And in case of time, it would be capital T. So these things should be on your mind. M, L and T. So M for mass, L for length and T for time. So now if we know that the equation of motion, definitely you know this is a very important chapter of physics is motion, and in this chapter we will be studying about the equation of motion in the next classes. So if we just see that what is the equation of motion, as you see raise these things, and I need to find it out the dimension equation. What are those? Number one, we definitely know the equation of motion would be like this. We know this V is the final velocity, U is the initial velocity, A is the acceleration over time. So this is the first equation, and then second would be V plus U by 2 into T. And the third is V square U square 2AS, and number 4 is S is equal to UT plus half of T square. We usually write it on the third position, but it's okay. This is the equation of motion, and most of the cases, in case of mathematical calculations of motion, we must use these equations. And I'll definitely upload some classes on mathematical explanations how to input the data over this equation. And of course, we also can validate the equation would be through the dimensions. So that would be the dimensional equation. Like what? This is the velocity, final velocity. So in case of velocity, we know the dimension is L over T. That means LT inverse 1. So if we need to see that, if we need to validate the equation through the dimension, how we can do that? You see, the first time in case of left hand side, there is V. So this is final velocity, and we know the dimension of velocity is L over T. So this must be like that. So it would be LT inverse 1. And if we see there is two things is getting plus inside, and what is the right hand side? So right hand side would be U and AT. We don't need to plus it again, but you see this U is actually the initial velocity, and though it's a velocity, the dimension would be same. So it would be similar L over T, which is LT inverse 1. And in case of AT, we know this is acceleration times T, and we know here we wrote that A is LT inverse 2 into time. So if we just make it a multiplication here, we will find LT inverse 1. So we got the same dimension in left hand side and right hand side. Somebody can say so that we can make it plus L over T and L over T plus 2L over T. No, it should not be. So it is equal in left hand side and on right hand side. So we also can validate the equations through the dimensional equations. And if you see the last one, we will find it like this one. So if we do it, S equal to UT plus half AT square, then we will find how that left hand side is simply S. And we know this S is actually the displacement, and this is definitely length, and here this will be the dimension. And again, right hand side, we know there is U times T. So as you know that U is the initial velocity times T. So what will be the dimension? L over T times T. So if we divide it, so T and T would be raised, and this would be only L. And in case of half of AT square, you know half is a number. So you cannot count because it's not a physical quantity. So we will have at square here. So in case of a, this is acceleration, and we will find L over t square times t square. So now you can erase these things and you can find L. Here similarly, through the dimensional equations we find that left hand side and right hand side are equal. And similarly you also can do this to this. So this is the square of final velocity. So it would be L. So if I just find it at v square, so it would be L square t inverse 2, and it would be similar L square t inverse 2, and you know this is a and s. So in case of a s, we know the acceleration is L over t square into s, which is also the length. So this would be L. Hence it would be L square t inverse 2. So in both cases, in left hand side and right hand side, we will find the same thing. So through the dimensional equation, we also can validate this thing. So in case of understanding the dimension, you must know the definition, and you see what I did here, which is very simple. I know that you can do it, but in your exam paper, if a question comes from dimensions and through the dimensional equation you need to validate an equation like this, do it like that. So this is a very simple lectures on dimension, and on the next class I will be explaining how this equation came and how we can derive this. So see you on the next class, and please when you study physics and when you see my lectures, and if you don't understand anything and if you have any sort of recommendations, do let me know and I'll definitely take care of it. Take care and see you on the next class. Bye.